Hi, this is educator.com, and today we're going to learn about modified sine waves. So we're going to learn how to analyze and graph these functions given by, instead of just talking about sine x and cosine x, now we're going to talk about, we're going to throw a whole bunch of constants in there. So we'll talk about a sine of bx plus c, and then throw a constant outside plus d, and the same kind of thing with cosine. So that takes a basic sine or cosine graph and it moves it all around. So we're going to learn some vocabulary to describe those movements, and we're going to learn how to graph those. So first of all, some vocabulary. Remember, we're talking about the graph a sine bx plus c plus d. So we're talking about sine waves. So these are functions that basically have this shape like sine x. But they may be moved in different ways, and we need some vocabulary to describe the different ways they can be moved. So the first word we're going to learn is amplitude. The amplitude of the sine wave is the vertical distance from the middle of the waves to the peaks. So what that represents graphically is this distance right here. That's the amplitude. And of course that's the same as this distance. That's also the amplitude, but you can measure it either way. If the wave is moved up, if it's maybe floating up above the x-axis, somewhere like that, then the amplitude is still the distance from the middle of the wave to the peaks. In terms of equations, it's very easy to spot the amplitude. When you're given a sine of bx plus d, or sorry, a sine of bx plus c plus d, the amplitude is just that number a. Or if the a is negative, you just take the absolute value. So it's just the positive version of that number a. That tells you the amplitude right there. So that tells you how far up the wave is going to the peaks, how far down it's going to the valleys. The period of a sine wave, I'll show this in red, is the horizontal distance for the wave to do one complete cycle from one peak to the next peak. So that is the period right there of that wave. That's a period. On that one, that's the period right there. And remember, when you're working out the equations, remember that if you have sine of x, that has period 2 pi. It takes 2 pi to repeat itself. We learned that when we looked at the original sine graphs. If you have sine of 2x, that makes it wobble up and down twice as fast, so the period would be pi. Sine of 4x, the period would be pi over 2. And the pattern that you notice here is that the period is given by 2 pi over the coefficient of x, 2 pi over b. So the b there tells you what the period is, not the b itself, but you plug b into that equation, and that tells you what the period is. Two more vocabulary words we need to learn. The phase shift of the sine wave is the horizontal distance that the wave is shifted from the traditional starting position. So let me rewrite the equation here. A sine of bx plus c plus d. So the traditional starting position for sine would be at 0, 0. And the traditional starting position for cosine would be at 0, 1. So those are the traditional starting positions, but the phase shift will move the graph to the right or the left. In these equations, it's given by negative c over b, and that seems a little mysterious, so let me explain that a little bit. We can write this bx plus c as, well, first of all, we can factor b out. We can write that as b times x plus c over b. And then we can write that as b times x minus negative c over b. So that's where that negative c over b comes from. If you have trouble remembering that formula, negative c over b, you can go through this little process to remember that. X minus c over b, that shows you that it moves it c over b units to the right. So let me draw that. I'll draw that in blue. If you're starting with a sine curve, the phase shift is the amount that it moves over. So that's the phase shift right there. It moves it over negative c over b units. If you're starting with a cosine curve, that's that phase shift right there. And finally, the vertical shift is what happens when you take the graph and you just move it up or down vertically without changing anything else. So again, let me start with a sine curve. And if we apply a vertical shift to that, that amount right there, I'll draw this in red, that's the vertical shift. And that's a little bit easier to pick out from the original equation than some of the others, because that's just the d in the original equation. So if you move it up or down, you're moving the whole graph up or down by an amount of d. So this can get pretty tricky. We're starting with the basic sine and cosine curves, but then we're moving them around and stretching them out and moving them up and down in all different ways. It's a little bit tricky, but we'll go through some examples and you'll get the hang of it. So in our first example here, we're given an equation 3 cosine times 4x plus pi, all plus 2. And we have to identify all these various things, the amplitude, the period, the phase shift, and the vertical shift. And then we're going to draw a graph of the function. And the key thing here is that if you identify these things in order, then it becomes very easy to pick them out using the equations, and then the graph isn't too hard as long as you do all these things in order. So the amplitude remember, that's just the number on the outside, the a in the original equation. Let me write down the original equation. A times cosine of bx plus c, all plus d. So the amplitude is just the a right there. So that's the 3. The period is 2 pi over the b, 2 pi over b. So the b there is 4, so that's 2 pi over 4, which is pi over 2. The phase shift is negative c over b. Well, our c here is pi. Negative pi, b is 4, so that's negative pi over 4. And the vertical shift is just that last term d, which is 2. So those are the answers to the first part of the question. trickier part is doing the graph, and there's a general strategy for doing these graphs that sort of always works, but you really have to follow it closely. And the strategy is to start with a basic cosine graph, which hopefully you remember how to do it. You start with a basic cosine graph, and then you kind of move it around according to each one of these parameters. And the key thing here is you have to do it in order. You have to do amplitude, period, phase shift, and then vertical shift. So let's see how that works out. Let me draw a basic cosine graph, and then we'll try moving it around according to these different parameters. So remember, a basic cosine graph, there's pi, there's 2 pi, pi over 2, 3 pi over 2. Basic cosine graph starts at 1, goes down to 0 at pi over 2, -1 at pi, up to 0 at 3 pi over 2, and it's 1 again at 2 pi. So that's a basic cosine graph. You pretty much have to remember that to get started here. Now, the first thing we're going to do is we're going to change the amplitude. So let me keep track of this as I go along. First one we graphed was cosine x, just y equals cosine x. Next thing we're going to graph is 3 cosine x, so we're going to bring in the amplitude. What that does is that stretches up the peaks and it stretches down the valleys by a factor of 3. So I'm going to draw the same shape graph, but 3 times as tall and 3 times as deep. So instead of going from 1 to -1, it goes down to -3 and up to 3. So that second graph I drew there was 3 cosine x. The next one is to introduce is the period. The period is supposed to be pi over 2. And remember, the period is the amount of horizontal distance between one peak and the next peak. Well, my current peak is, so I'm going to change the period to pi over 2. So what I'm really graphing here is 3 cosine 4x. So what that's going to do is, instead of having period 2 pi, it shrinks it horizontally, or it compresses it horizontally, so that it does a complete period in the space of pi over 2. So there's pi over 2 right there. I need to do a whole period between there and there. So every pi over 2, it does a complete cycle. So what I just drew there was 3 cosine 4x. The phase shift now I'm going to introduce is -pi over 4. That means it moves it pi over 4 to the left. And it's getting a little bit messy. I'm going to see if I can draw this in red, and we'll see if it's still visible. Now, instead of going from 0 to pi over 2, I'm going to draw my graph from -pi over 2, from -pi over 4 to pi over 4, because we're moving it to the left by pi over 4. So that's the graph in red there, 3 cosine of 4x plus pi, because I've introduced the phase shift in there. And now it's really going to get messy if I try to draw any more on the same axes, so I'm going to set up a new set of axes. So we had pi over 2, pi, -pi over 2, and I'll redraw the red one on this set of axes. -pi over 2, and that one was going from 3 to -3. So remember the red one is the previous graph shifted over by negative pi over 4. Finally, we need to introduce the vertical shift of 2, and I'll do this last graph in blue. That takes the entire graph and raises it up by 2 units. So that means instead of going from 3 to negative 3, it's going to go up to 5. And instead of going all the way down to negative 3, it only goes down to negative 1. Let me label that more clearly. Negative 1. So I'll draw this one in blue. This is now 3 cosine of 4x plus pi, and I'm introducing the vertical shift of plus 2. So I'm taking the graph and I'm moving it up 2 units there. So that blue graph at the end is our final function. So this is really a pretty complicated process. There's a lot of steps involved, but each individual step is not that hard, and if you do them in order and you're careful about each one, it's not too bad. So let me just recap there. We started with the original graph of cosine x. So that's the starting point. Then you introduce the amplitude, and that stretches it vertically by a factor of 3. It stretches it up and down. You introduce the period, which compresses it horizontally. You introduce the phase shift, which takes the whole thing and it moves it to the right or the left. And finally, you introduce the vertical shift, which takes the whole thing and moves it up or down. Remember, it's important to do these in order. Amplitude, period, phase shift, vertical shift. If you do those out of order, then they'll mess each other up as you go along. So you really want to do those in order. You'll want to practice several of these, so let's get moving on another example. Here's another example. Same questions here. Amplitude, period, phase shift, and vertical shift of the following function. Remember, we can read these off quickly, just remembering the formula A sine of bx plus c plus d. And if we remember, if we can figure out what A, B, C, and D are, we have formulas for all 4 of these properties. So amplitude, that's the A, or if the A is negative, you make it positive. So that's the absolute value of A, which is just 2 here. The period is 2 pi over the B. The B is 2 here, so that's pi. The phase shift is negative c over b, which is, okay, c is negative pi over 3. So negative of that is pi over 3 divided by 2 will give us pi over 6. And finally, the vertical shift is d, which in this case is just 0. And finally, the fun part, we get to graph the function. And remember, you always start with your basic sine or cosine graph, and then you start moving it around according to these different parameters, but you've got to keep these parameters in order. So let me start with, this one's a sine graph, and I know the basic shape of the sine graph. I've got that memorized. Pi and 2 pi. I know sine always starts at 0, goes up to 1, comes back down to 0, to negative 1, and then back to 0. So there's 1, there's negative 1, there's pi, pi over 2, 3 pi over 2. So that's my basic sine graph. So that's the first thing I graphed there, sine x. Again, you remember this, the graphs of sine and cosine x. Now we start introducing these other attributes, and it's important to go in order. So first of all, we're going to introduce the amplitude. And that's the the amplitude is 2, but we're really multiplying the graph by -2. So -2 sine x is what I'm going to graph next. -2 sine x, that stretches it vertically because of the 2, but it also flips it vertically. So instead of starting by going up, it's going to go down. Goes down to -2, up to 0, up to 2, and back down to 0. So that first one was a little lopsided. Let me see if I can make that a little smoother. Okay, so we've got -2 sine x. Look, it's got a bigger amplitude than the original graph, and it's flipped over because of the negative sign. Next thing to introduce is the period. The period is supposed to be pi, so I'm graphing -2 sine of 2x. That speeds the whole thing up. It shortens the period because the period is now pi instead of 2 pi. So I need to do that entire graph in the space of pi instead of 2 pi. So there, that one that I just graphed, I shortened the period to be pi instead of 2 pi. So the period is now pi on that new graph. Next, we've got to do the phase shift. That's pi over 6 units to the right. So the phase shift, what I'm about to graph, is -2 sine of 2x minus pi over 3. So that takes the whole graph and it shifts it over pi over 3 units to the right. Let me do this one in red. So I'm going to take that last graph and shift it over pi over 3 units to the right. So instead of starting at 0, 0, it starts at pi over 3. And it's going to come back down to 0 at 5 pi over 6. Or sorry, the phase shift is supposed to be pi over 6. Pi over 6. So I'm going to move everything over by pi over 6. So instead of starting at 0, I'm going to start at pi over 6 and come back at pi over 2 plus pi over 6, which is actually 2 pi over 3. So that red curve that I graphed there is -2 sine of 2x minus pi over 3. The last step is to do the vertical shift, which is 0, so we don't have to move the graph at all, which means we're done. So this last graph is the one we want. Again, it's a matter of breaking these equations down into their parts. It's very complicated if you kind of look at the whole thing, but if you look at each step and you keep the steps in order, then it's not too hard. So you remember the equations for amplitude, period, phase shift, and vertical shift. Once you got those, you start with your basic sine x graph, then you change the amplitude, which stretches it out up and down, or it might flip it. You change the period, which compresses it horizontally. you do the phase shift, which takes the whole thing, and without compressing it, it moves it to the right or the left. And finally, the vertical shift moves it up or down. So you can just keep moving these graphs around until you build up the equation that you're looking for. So this one's a little bit different. We're asked to find a sine wave, and this time we're told what all the properties are. We're given the amplitude, the period, the phase shift, and the vertical shift. So we want to find an equation, and we want to graph the function. So I'm going to kind of build these up the same way we were building the earlier graphs. I'm going to start with a basic sine x. So that's my basic sine wave. Now I want to give it amplitude 2. And remember, 2 was just the number on the outside, the a. Let me rewrite that equation. A sine of bx plus c plus d. So amplitude 2 means a is 2 sine x. Now, period 4 pi. Period, remember our equation for period. Our equation for period was 2 pi over b. And that is supposed to be equal to 4 pi. That, when you solve that out, that tells us that b is equal to 1/2. So the b has to be equal to 1/2. So that means our equation is now 2 sine of 1/2 x. So we've incorporated the period. Phase shift. Is supposed to be pi over 2. But remember, the phase shift, our formula for that is negative c over b. B is already, we figured out, is 1/2. So that's negative c over 1/2. And so if we do a little bit of algebra here, we get 1/2 pi. I'm cross multiplying here. 1/2 pi is equal to negative 2c. And so c is equal to negative pi over 4. So I got that from the equation negative c over b is equal to pi over 2. And I already figured out my b. Now I can figure out my c. So the next part of that equation is 2 sine of negative 1/2 x minus pi over 4. Or sorry, 1/2 x minus pi over 4. And finally, I want to talk about the vertical shift, which is supposed to be 1, and that's the d. And so finally, my equation is 2 sine of 1/2 x minus pi over 4 plus 1. So that is the sine wave that I'm looking for. And now I want to graph that thing. I start out with a basic sine wave. Pi, 2 pi, pi over 2, 3 pi over 2. Basic sine wave starts at 0, goes up to 1, back down to 0 at pi, down to negative 1, back up to 0 at 2 pi. Basic sine wave. Now I introduce these properties in order. So I start out with the amplitude. Amplitude's supposed to be 2, so I'm going to stretch this thing up. Instead of going from 1 to negative 1, it's going to go up from 2 up to 2 and down to negative 2. So I stretch the thing up. And down. Period is 4 pi. So that means the thing stretches out so that it only does one cycle every 4 pi. So that means I have to extend my graph quite a bit here. 3 pi, 4 pi. So I stretch the thing out so it only does a cycle every 4 pi. Okay, now phase shift pi over 2. That means the thing is going to shift pi over 2 units to the right. I better draw a new set of axes here. So I've got pi, 2 pi, 3 pi, and 4 pi. 5 pi. And what I want to do is take the graph that I had above and move it pi over 2 units to the right, because we have phase shift pi over 2. So instead of starting at 0, I'm going to start at pi over 2. And I go up to there, back down to 0 at 2 pi plus pi over 2, back down to negative 2 between 3 and 4 pi, and back up to 0 there. So I'll connect these up. And finally, I have to do one with vertical shift 1. So that means I take the whole graph and I move it up by 1 unit. So that means instead of peaking at 2, it's going to peak at 3 now. And actually, instead of going down to negative 2, it gets moved up by 1 unit, so it's going to only go down to negative 1. So let me draw this last final curve in red. Everything gets moved up by 1 unit. So I'm going to plot some points here, moving everything up by 1 unit. So that final curve is the one we want. That's 2 sine of negative, or 1/2 x minus pi over 4 plus 1. Again, it's a complicated procedure, but if you take it step by step, each one of the steps is not too hard. So first we kind of reconstructed the equation from these parameters that we were given. Basically, we figured out A, B, C, and D from these parameters that we were given by sort of reverse engineering the formulas, 2 pi over b, negative c over b, and the d. And then we went through step by step. We started with a basic sine curve, and we changed its amplitude, stretched it vertically. We changed its period, which stretched it out horizontally. We changed its phase shift, which moved it over horizontally, not stretching, but just moving it without stretching. And then we did the vertical shift, moving it up and down. So you should practice a few of these curves on your own. We'll come back and try some more examples together later.